Picture this: two cars parked side by side, one a sleek, silent electric vehicle, the other a traditional car with a rumbling internal combustion engine. They might seem similar, but their environmental stories are vastly different. This is a tale of those differences, a journey from their creation to their eventual retirement. Buckle up as we explore the life cycle analysis of electric vehicles versus internal combustion engine vehicles. We'll delve into their manufacturing, use, maintenance, and disposal to understand their true environmental costs. Let's start at the beginning with the raw materials. Electric vehicles rely heavily on batteries, which require lithium, cobalt, and nickel. Mining these materials can impact the environment, especially in countries with less stringent regulations. On the other hand, internal combustion engine vehicles depend on steel, aluminum, and plastics. While these materials are more readily available, their extraction and processing also come with environmental costs. Next stop, the factory floor. Manufacturing an electric vehicle, particularly its battery, is energy intensive. The process can generate significant emissions depending on the energy source used. Building an internal combustion engine vehicle with its complex engine and transmission also releases emissions. However, the overall energy consumption and emissions during electric vehicle production are currently higher due to battery production. Now the open road. This is where electric vehicles truly shine. They are incredibly energy efficient, converting a much higher percentage of energy into motion compared to internal combustion engine vehicles. They produce zero tailpipe emissions, contributing to cleaner air in cities. However, the environmental impact of electric vehicles depends on how their electricity is generated. If it comes from renewable sources, their carbon footprint shrinks dramatically. Meanwhile, internal combustion engine vehicles continuously emit pollutants and greenhouse gases as they burn fossil fuels. Section 5. Keeping cars running. Maintenance matters. Every car needs a checkup now and then. EVs, with their simpler electric motors and fewer moving parts, require less maintenance. This translates to fewer oil changes, less waste from used parts, and a lower environmental impact. ICE vehicles, on the other hand, require regular maintenance, including oil changes, filter replacements, and emissions checks. This maintenance generates waste and consumes additional resources. Section 6. Afterlife of a car, recycling and disposal. What happens when a car reaches the end of its life? EVs pose a unique challenge: battery recycling. While EV batteries can be recycled, the technology is still developing and the process can be expensive. Proper disposal is crucial to prevent environmental contamination. ICE vehicles have established recycling processes for most of their components. However, the disposal of engine fluids and other hazardous materials requires careful management. Section 7. The big picture, comparing environmental impacts. Taking all stages into account, EVs currently have a higher environmental impact during production due to battery manufacturing. However, they quickly compensate for this during their lifespan with lower emissions and less maintenance. As renewable energy sources become more prevalent, the environmental advantage of EVs will further increase. ICE vehicles, while having a lower initial impact, continue to produce emissions throughout their lifetime. Section 8. The price tag, costs and incentives. The environmental benefits of EVs are clear, but what about the cost? Electric vehicles, or EVs, are often praised for their lower emissions and reduced environmental impact. However, the financial aspect is a significant consideration for many potential buyers. Currently, EVs tend to have a higher upfront cost than comparable internal combustion engine or ICE vehicles. This price difference can be a barrier for consumers who are considering making the switch to electric. This is largely due to the battery, which is a significant expense. The lithium-ion batteries that power EVs are costly to produce, and this cost is reflected in the price of the vehicle. However, advancements in battery technology are continually being made, which could help reduce these costs over time. However, governments worldwide are offering incentives and subsidies to make EVs more affordable and encourage their adoption. These incentives can take many forms, such as tax credits, rebates, and grants. In some regions, there are also benefits like reduced registration fees, access to carpool lanes, and free or discounted parking. As technology advances and production scales up, the cost of EVs is expected to decrease, making them a more accessible option for consumers. Economies of scale in manufacturing and improvements in battery efficiency are key factors that will drive down prices. Additionally, the growing second-hand market for EVs provides more affordable options for those looking to make the switch. The future of transportation is leaning towards electric, and with the right incentives and technological advancements, EVs could soon become the norm rather than the exception. Section 9. Powering the future electricity generation. In this section, we delve into the intricate relationship between electric vehicles and the sources of electricity that power them. Understanding this connection is crucial for grasping the full environmental impact of EVs. A crucial factor in the environmental impact of EVs is the source of electricity used to charge them. The cleaner the energy source, the more environmentally friendly the vehicle becomes. This is why the origin of the electricity is so important. If the electricity comes from fossil fuel power plants, EVs will still indirectly contribute to greenhouse gas emissions. This is because fossil fuels such as coal and natural gas release significant amounts of carbon dioxide and other pollutants when burned to generate electricity. Therefore, even though EVs themselves do not emit pollutants, the electricity they use can still have a substantial carbon footprint. However, as we transition to a cleaner energy grid with more renewable sources like solar, wind, and hydro, the environmental benefits of EVs will become even more significant. Renewable energy sources produce electricity without emitting greenhouse gases, making them a much cleaner option. The integration of renewable energy into our power grids is essential for maximizing the positive impact of electric vehicles on the environment. The shift to electric mobility goes hand in hand with the transition to clean energy. As more renewable energy sources are developed and integrated into the grid, the overall carbon footprint of electric vehicles will continue to decrease. This synergy between clean energy and electric vehicles is a key component in our efforts to combat climate change and create a sustainable future for generations to come. Section 10, the road ahead, technological advancements. The world of EVs is constantly evolving. Battery technology is rapidly improving, leading to increased range, faster charging times, and longer lifespans. Researchers are also exploring alternative battery chemistries that use more abundant and less environmentally harmful materials. These advancements will further reduce the environmental impact of EVs and make them a more viable option for a wider range of consumers. Section 11. Conclusion. Driving towards a greener future. In the race towards a more sustainable future, electric vehicles have emerged as a frontrunner. These innovative machines are not just a trend, they represent a significant shift in how we think about transportation and its impact on the environment. While they face challenges, particularly in battery production and recycling, their potential to reduce our environmental footprint is undeniable. The process of creating and disposing of batteries is complex and requires careful management to ensure it does not negate the environmental benefits of electric vehicles. However, advancements in technology are continually improving these processes, making them more efficient and less harmful to the environment. As technology advances and renewable energy sources become more prevalent, EVs will play an increasingly important role in mitigating climate change and creating a cleaner, healthier planet for generations to come. The integration of solar panels and wind energy to power these vehicles is a promising development, reducing reliance on fossil fuels and decreasing greenhouse gas emissions. The journey towards a greener automotive future is well underway, and EVs are leading the charge. With continued innovation and support from both the public and private sectors, the widespread adoption of electric vehicles is not just a possibility, but an inevitability. This transition will not only benefit the environment, but also improve public health by reducing air pollution and its associated health risks. The road ahead is clear, and the destination is a sustainable, eco-friendly future where electric vehicles are the norm rather than the exception.